Okay, so student, last time we have seen about your reflection of a transfer wave in the two mediums. That is, first we have seen reflection of a transfer wave in the denser medium, and then we have seen reflection of a transfer wave in the rarer medium. Now, transfer wave means what? There is an alternate crust and trough. So, in previous lecture we have seen when the crust is incident on a denser medium, at that time particle velocity is in upward direction and wave velocity is towards the rigid wall. When it is incident on rigid wall is not free to vibrate. Therefore, all energy will get rebound, and therefore particle velocity and wave velocity both will get reversed. So now in reflection, particle velocity becomes downward, wave velocity will become away from the rigid wall. Therefore, the crust will reflect it as a drop. And therefore, there is a change of phase of 180 degrees when transfer wave will get reflected from the denser. Similarly, we have seen when transfer wave is incident on a rarer medium. Rarer medium means what? The particles of the medium are ready to accept the energy. So as soon as crust will come, rarer medium absorb the energy. So particle velocity become continue in the rarer medium. Only wave velocity will get reversed. Therefore, your crust will be reflected as a crust. So there is no change of phase. Fine? That last time we have finished. Now today what we are going to see? The reflection of longitudinal wave from the denser medium. So this is nothing but your denser medium, which is nothing but your wall. And a longitudinal wave is incident. Now longitudinal wave means what? It consists of alternate compressions and refraction. Now your sound wave is a longitudinal wave. And that longitudinal wave as a sound wave is also called as a pressure wave. So when a longitudinal wave or a sound wave is incident in the form of compression on a rigid wall, at that time compression means what? Particles get compressed. So particle velocity and wave velocity both are parallel towards the rigid wall. As soon as compression incident on a rigid wall, now what is the property of rigid wall? Rigid wall particles are not free to vibrate. Therefore, compression gives its energy to the rigid wall. But rigid wall is not ready to accept that energy. And as it is not ready to accept the energy, all amount of energy will get rebound. Energy get rebound means what? Particle velocity both and wave velocity both changes its direction. During incidence, particle velocity, wave velocity both will be directed towards the rigid wall. After reflection, wave velocity, particle velocity both will get reversed. Reverse means what? They will start moving away from the rigid wall. Therefore, compression will be reflected as a compression. Is it right? Means there is no change of phase. Fine? Because in incidence wave also both are parallel, but direction is towards the wall. In reflection, again wave velocity, particle velocities are parallel, but direction is away from the rigid wall. So compression will get reflected as a compression when longitudinal wave is reflected from the denser medium. Means what I can say that there is no change of phase. So no change of phase. Clear? Now, second case I can say that if there is a rarer medium and now the compression will get incident here. So your compression will get incident as an incident wave. So here your incident wave in the form of compression is incident on the error medium. Compression is what? Your particle velocity and your wave velocity. Both will be towards the rigid. Right? Now, this compression gives its energy to the rarer medium. Now, what is the property of rarer medium? Rarer medium particles are ready to vibrate. So, whenever it will accept the energy, whenever energy is incident, energy will be accepted by the rarer medium particle. And now rarer medium particle starts vibrating. Now rarer medium particles start vibrating means what? Your particle velocity will get continued in the rarer medium, but due to reflection, wave velocity will get reversed. Means particle wants to move in the forward direction, wave velocity wants to move away from the medium. So there will be the increment in the volume of the particle, medium. So increment in the volume of the medium means what? Your compression will be reflected as a rarefaction. Why? Because particle velocity and wave velocity both are traveling in the opposite direction. So the compression will get reflected as a rarefaction whenever your longitudinal wave is incident on the rarer medium. So compression reflected as a rarefaction. So there is a change of phase. And that change of phase is what? Through 180. So there is a change of phase. And that change of phase will be through 180. Get it? So this is nothing but your reflection of longitudinal waves from the rarer. And the first diagram shows you the reflection of longitudinal wave from the denser. Right? So recall this diagram so many times through the videos. So you will come to know that how the changes will take place. And there are so many MCQs related to this. Got it? Again I am revising. Actually this portion is deleted from your syllabus. But if you don't understand how the transfer wave and longitudinal waves are get reflected from denser and rarer medium, you will not come to know the next topics, which is nothing but pipe is at open, pipe is open at one end, pipe is open at both ends. Then vibration of string. To understand that all the topics, you need this as a basic. Clear? So here is nothing but your reflection of longitudinal wave through denser medium as well as through rarer medium. Okay? Fine. Now our next topic is nothing but your superposition of waves. That is your actual chapter name. Your name of the chapter is nothing but superposition of waves. So now what that superposition of waves? Now superposition of waves. Just consider now our online lectures are going on. You're attending your online session, and during that you are always wearing the speaker, this earphone. Why? To avoid the other disturbance. Because you are in a single room, but somebody will come inside your room. Somebody will talk. Somebody will make certain noise. So that noise will get disturbance. That noise creates a disturbance in your online lecture. And therefore, what you are using, young generation always uses the headphones to attend the lectures, to attend your what I can say enjoyable music, to observe your movies, to see your movies. Is it right? So means what? Anybody is coming inside your room, making certain voice, means that is one sound wave, and your music is going on or your online lecture is going on, that is the second sound wave. So through the room, which is nothing but your medium, the two sound waves are traveling. And when that two different sound waves are traveling, they will cross each other. And when they will cross, they will create a unwanted disturbance. Means you will not get a clear sound. This is one example. I can give the second example as well. Suppose at a time you are 3-4 friends are together. When college is going on, not now. So when college is there, at a time 2-3 persons are talking. So nobody understands what one particular person is talking. Or very enjoyable example, that is your teacher is teaching from the dais and last bench students, 2-3 students are talking at a time. But teacher will get that disturbance. Teacher immediately catch that somewhere there is a noise in that particular corner. Why? Because teacher voice is one sound wave and some students are talking at a time. So that sound wave, they are traveling through the medium as a classroom. Somewhere they will cross each other. And at the crossing point, they will produce a combined effect of the sound. And therefore, the teacher will immediately come to know that where unwanted voice is set. That is to be called as your principle of superposition. Now, this principle of superposition of waves not only takes place in case of sound waves, but it also takes place in case of light waves. Now, your Ganpati festival is there just 15 days afterward. So, you are knowing that so many times you have seen such type of decoration. That is, this is the stage. At the corner of the stage, suppose here is a red focus light, and somewhere here is nothing but your yellow focus light. So what happens? This red focus light will give us this red beam of light. And here this yellow focus will give us the yellow beam. So here is the red color, here is the yellow color, but when they cross in this particular region, at this crossing region, there is a combination of red plus yellow, which is nothing but your orange color. Right? And in this orange color, we are going to put our Ganpati Murti. So that is nothing but a type of decoration. So what it uses? It uses the principle of superposition of waves. So what is that? Red color wave is crossing through the medium. Yellow color wave is also crossing through the medium. At one point, they will intersect each other. And at that intersecting region, they will produce a combined effect. So red and yellow light, they will get mixed together. So you will get not a red color, not a yellow color, but you will get the orange color in that intersection region. But if you avoid the intersection region, see here, furthermore, avoid this cross region and consider independent region. When this red light will come out from the cross region, here is you will get the red light. And yellow light here at this point I am getting the yellow. Means when they will cross, only in the crossing region, they will produce a combined effect. And once the crossing will over, they will travel independently with their original. So that effect is to be called as your principle of superposition of waves. So see, principle of superposition of waves will not only take place in the sound wave, but principle of superposition of waves will also take place in case of light. Now in detailed manner, I can say that one sound wave, so sound wave I can say compressions and rarefaction. Here is the compression and here is the rarefaction. This one wave is crossing compression and rarefaction towards the right hand side. And here is the another wave with compression and rarefaction will be traveling towards the left hand. What happens? As these waves are moving towards each other, at one particular point, they will cross each other. And at the crossing point, they will produce the combined. What is that? Let's call that this first wave has a displacement 1-1. Second wave has a displacement 1-2. When they will cross, at crossing point, displacement. Net displacement is nothing but the vector sum of the displacement produced by each wave. And after crossing, they will behave as an independent wave. That is to be called as your principle of superposition of waves. So for principle of superposition of waves, at least there should be the two waves. If there are more than two, no problem. The principle will take place. But if there is only one wave is traveling through the medium, then principle of superposition of waves will not. Minimum there is a requirement of two mediums should travel through the medium. So now what I can say, the statement, according to principle of superposition of waves, when two or more than two waves are traveling through a medium and they will get superimposed, then they will produce a combined effect, which is nothing but the vector sum of displacement produced by each wave independently. And after that, the waves will behave as an independent wave. Means after combining, after crossing, the wave will behave. Like means suppose this one wave is going cross, so one wave produce y1, another wave produce y2. But only at the combined point, there is a vector y1 plus vector, and that is to be called as your principle of superposition of waves. Clear? Now, here I can draw the diagrams, and in that diagram, if I am saying that I am showing the waves in the form of transfer wave. So let's consider this is the one crust is traveling towards the right hand side, and there is another wave whose crust is traveling towards the left hand side. So one crust is here, another crust is here. Slowly they will come together. Is what I can say that there is a superposition of two waves having equal amplitude. Their amplitudes are same. Amplitude means distance from the mean position. This distance, this is nothing but the amplitude. So both the waves have the amplitude and they are traveling in the opposite direction. Right? But crust of first wave is here and here is also the crust of first wave. So both the crusts are traveling towards each other. So crust. So what I can say that two waves are in phase. Now when they are coming towards each other, so slowly they will come together. Slowly they will come together means what? This distance, this dotted distance will continuously goes on decreasing. And at one moment, at one time interval, this is the first crust, and the blue color crust this is the first wave crust, and for blue color line, I can show the second crust. Like this one. Means what happened? Both the crust at one particular moment, both the crust will get overlapped to each other. And when both the crust will get overlapped to each other, the total displacement is a vector sum. So if first wave produces a displacement y1, second wave produces a displacement y2. So the net displacement will goes on increasing. It will become vector y1 plus vector, means the net wave displacement will goes on increasing like this. Means resultant displacement will goes on. Means one displacement will get overlapped, one crust will get overlapped with another crust. So both the crust displacements will get added. The resultant displacement will goes on increasing. Resultant displacement will goes on increasing means resultant amplitude also increases. So AR is nothing but the resultant amplitude. And first wave has amplitude A, second wave has amplitude A. So A plus A will get added and it will become as a crust. Means net amplitude increases. And such type of combined effect is to be called as a interference, and that type of interference is to be called as a constructive interference. Here, one amplitude will get constructed over the other amplitude, and therefore net amplitude will goes on. So the one amplitude will get constructed over other, so the net amplitude will go down increasing. Means it is in the language of construction, what I can say that the one floor will get top up on the another floor, so the height of the floor will go on. So that is nothing but called as a constructive. So in constructive interference, what I am getting, I can say characteristic of constructive interference. To occur constructive interference, the two waves which are traveling through a medium, that two waves must be in phase. That is the first characteristic. Therefore, second characteristic, the resultant displacement of that crossing point will goes on increasing. It becomes as a vector sum of individual displacement. Then third, the resultant amplitude will also goes on, and we have fourth characteristic, that is intensity of sound wave is directly proportional to the square of amplitude. Now here square of amplitude, I can say that resultant amplitude square. So if this AR will increases, means automatically the intensity will also become maximum. And if intensity will become maximum, means in this particular region where the amplitudes of one wave will get constructed over other, in this particular region the sound will be loudest. And if the sound is loudest, that type of interference I am going to say as a constructive. This is for sound wave. But if light wave is there, what I can say that the amplitude of one light wave is constructed over the amplitude of second light wave. So the net amplitude will increases. So the light will become more bright. So that region is to be called as the brightest region, or that region is to be called as a bright region. And if we are talking about the sound, I can say that the sound is loud. So I am getting here as a loud sound, and then I can get this as a principle of superposition of. Clear? And this type is to be called as your constructive interference. So for constructive interference, I will again repeat that steps. Just concentrate very carefully. There are two sound waves of equal amplitude, and I am considering the crest of one wave and crest of another wave. They are approaching towards each other. They are moving towards each other. Now, as they are moving towards each other, slowly the distance between the crest will go on decreasing. And at one time interval, the crest of one wave get overlapped with the crest of another wave. And therefore, the resultant displacement will go on increasing. So the net displacement becomes as a vector y is equal to vector y1 plus vector. Now displacement increases means what? Amplitude also rises. So resultant amplitude, which is indicated by letter AR, is equal to A plus A. Why? Because both the amplitudes are same. So A plus A means it will become 2. So amplitude of resultant is increased. If amplitude increases, automatically the intensity of wave, which is directly proportional to the square of amplitude, so that intensity will become directly proportional to AR square. AR is maximum, so square is maximum, so intensity is maximum. And if in that particular region where the intensity is maximum, means sound become loudest. If light is there, light will become more bright. So for sound I can say that loud sound will be heard. For light I can say that bright region. And like that manner, we will come across with this constructive interference. So for this constructive interference, these are the 4 characteristics. Clear? Any doubt here? Now here for MCQ question, just concentrate. Both the amplitudes are same, so resultant amplitude will become 2A. So here your Imax value, approximately I can say that Imax is equal to some constant K of proportionality sign. AR value is 2A, so it will become as a 4K square. So this is nothing but my maximum intensity value during the constructive if amplitudes are same. But if I am saying that amplitudes are different, first wave has amplitude A1, second wave has amplitude A2. If it is so what I can say that AR will become A1 plus A2. If it is A1 plus A2, so what I can say that I max can be written as K into bracket A1 plus A2 bracket if amplitudes are not getting. So for MCQ, you have to remember these formulas very well. That is, what is the intensity maximum? If the two waves have same amplitude are under constructive interference, and what is intensity maximum? When two waves have a different amplitude, they will get interference with each other in the constructive manner. And that type of interference is to be called as a constructive interference. Clear? So in constructive interference, four things: in phase, displacement maximum, amplitude maximum, intensity maximum. So the sound is loudest. Finished. That is the constructive interference. Fine? Then, suppose I am going to consider the opposite case now. That is, there are two waves, but one wave whose crust is traveling, and for other wave, its trough is traveling. But the thing is, both the amplitudes are equal, so amplitudes are same as it is. So one crust and one trough. So one positive phase, another is nothing but the negative. Means they are, at that time I can say that the two waves are out of phase. Suppose I am going to see the such interference. Now, one crust, one trough, they are moving towards each other. They are approaching towards each other. So two waves having equal amplitude, but they are out of phase. It is called out of phase. Are approaching towards each other. So what happens? So now this one wave is coming here at some time interval. Here is its crust, and here is the another wave is approaching here, whose trough is there. So first wave has an amplitude in the upper side, so plus A. Second wave has an amplitude, whose amplitude is on the minus side, minus A. So plus A minus A, or in displacement language I can say that plus Y1, and here is nothing but minus Y. So plus Y1 minus Y1 means resultant Y will become as a vector Y1 minus vector Y. Minus sign indicates that its direction is opposite. Resultant amplitude A, I can write down resultant amplitude AR is equal to A minus A, which is equal to 0. Means in this crossing region, what I am getting, this wave becomes just a parallel line to the x-axis. And when they cross each other, crossing will over, then independently they will travel like this only. So when crossing will over, they will travel as it is. No problem. But only in the crossing region the effect will. Now what is the effect? Resultant displacement. Vector y is equal to vector y1 minus vector y. Means what happened? Resultant displacement is decreased. Okay, fine. Next, resultant amplitude. Amplitude, resultant amplitude, AR becomes A minus A, which is equal to 0. Means amplitude will become, if amplitude is 0, so I can say intensity, which is directly proportional to AR square, which is nothing but equivalent to 0. Means that intensity I am going to call it as a minimum intensity. And if their intensity is minimum, means I can say that low sound. In case of sound and in case of light wave, I can say that there is a dark region. And that type of interference is to be called as your destructive interference. So this destructive interference, in which what happens? Two waves are traveling through a medium are out of phase. Second thing, resultant displacement decreases. Third, resultant amplitude also decreases. Fourth, resultant intensity will become minimum or 0, and the region where we will get the very low sound or somewhat you will not hear anything. Intensity 0 means what? You will not able to hear anything. And in case of light, I can say that the dark region will be. And that type of interference is to be called as your destructive interference. Okay, so I'm getting here intensity 0 because amplitudes are same. But if I'm saying that here the two different amplitudes are there, like A1 and A2, such that your A1 is greater than A2. Then what I write here, intensity minimum is equal to K into bracket A1 minus A2. Bracket square. Right? And there is a decrement in amplitude. Decrementing amplitude means what? Intensity of sound will become low. If intensity is 0, we will not hear anything. But here, intensity is not 0. So I am getting a very low sound, which is not clearly hearable. So that is also the clear. So two types of superposition of waves you will get it. One is constructive interference, another is fine. So there are now so many questions. First is what is constructive interference and what is destructive interference. From the word constructive means construction, high. Displacement increases, amplitude increases. Destructive, low. Displacement decreases, amplitude decreases. Like that manner you can remember. This is the first question. Second question, characteristic of constructive waves and characteristics of destructive. So what is the characteristic of destructive wave? The two waves having either equal or different amplitude traveling through a medium arrive at one particular point out of phase. Second characteristic, therefore, their amplitude, resultant amplitude is vector y is equal to vector y1 minus vector y. Means displacement decreases. Third characteristic, therefore, resultant amplitude will also decrease. It will become AR is equal to A1 minus A2 or A minus A, which is equal to 0. Hence, intensity will become minimum or 0. And the region of that crossing region is to be called as a low sound region or no not hearable sound region. So these are the characteristics of this. Now you have seen the diagram, you have seen the characteristic, and something comes in your mind that these two things are opposite. एक में increase हो रहा है, एक में decrease हो रहा है, एक में maximum intensity एक में minimum intensity है, automatically your next question is nothing but distinguish between constructive interference and destructive. So you can get easily here 4 points. First column constructive interference, second column destructive interference. Constructive interference, the waves traveling through a medium arrive at a point in phase. Destructive, the two waves traveling through a medium arrives at a point out of phase. Right? अगर in phase है तो displacement resultant displacement increases. अगर destructive है तो resultant displacement will goes on decrease. Third, constructive interference resultant amplitude increases. Destructive resultant amplitude decreases. Constructive interference intensity is maximum. Destructive intensity is minimum. So maximum intensity means region is called as a loudest sound region, and minimum intensity means low sound region. So like that manner, you can distinguish between constructive interference and clear? Any doubt here? Now, whatever I have given you the formulas, and in this formula, I can recall that formulas of your resultant amplitude. I can say here for constructive interference. Constructive interference, and here is the destructive interference. Constructive interference amplitude AR is equal to 2A, provided that amplitudes are equal. अगर amplitude equal है, so I get resultant amplitude 2A. अगर destructive में क्या मिलेगा? AR is equal to, अगर amplitude 2 है, तो maximum intensity क्या मिलेगी? Maximum intensity K into 4A square. और यहाँ पे इंटेंसिटी मिनिमम क्या मिलेगी आपको? ये एक सेक्शन है. बट इफ देयर आर डिफरेंट एम्पलीट्यूड सच दैट A1 इज ग्रेटर देन A2, अगर ऐसी सिचुएशन है तो व्हाट आई गेट? AR इज इक्वल टू A1 माइनस A1 प्लस A, और डिस्ट्रक्टिव में मुझे मिलेगा AR is equal to A1 minus. Therefore, जहाँ पे आपके एम्पलीट्यूड ऐड हो रही है, वहाँ पे मुझे इंटेंसिटी मैक्सिमम मिलेगी, which is equal to K into bracket A1 plus A2 bracket, और यहाँ पे मुझे मिलेगा इंटेंसिटी is minimum, which is equal to K into bracket A1 minus A2. Right? But this case you will get it only constructive means waves are in phase. जब आपके दोनों waves phase, दोनों का phase same होगा, तब मुझे ये मिलेगा. दोनों का phase opposite होगा, that is out of phase, तो मुझे ये मिलेगा. लेकिन if I am saying that two waves are not in phase, not out of phase, but they are inclined to each other. अगर दोनों एक दूसरे को inclined है, पहले हमने क्या देखा? In phase मीन्स ऐसे आया, दोनों के क्रस्ट, या एक का क्रस्ट दूसरे का क्रस्ट, because they are traveling along the same. लेकिन अगर वो इंक्लिनेशन में आते हैं, तो वहाँ पे क्या होगा? They are not in phase, they are not in out of phase, तो कुछ अलग होगा. So at that time, how you can calculate the amplitude? That is our next topic. That is calculation of resultant amplitude in case of a superposition of waves. So that will be our next topic. So in the next lecture, we are going to see the expression for resultant amplitude of a superposition of waves. Yeah? Okay. So thank you very much.